All right, Mr. Ahmed here for 9.5 day 2. Goal for today is still working with sine and cosine. We're going to take a look at finding the sine and cosine of some special right triangles first, and then we'll kind of do a couple more example problems with angle of elevation and angle of depression. So taking a look at this special right triangle, it's a 45, 45, 90. So the side lengths are 1, 1, and the square root of 2, because the hypotenuse is equal to the leg times the square root of 2. And 1 times the square root of 2 is just the square root of 2. So we're going to first find the sine of 45. So if I look from this 45-degree angle, sine, I'll rewrite this again. So, ka, toa. All right, so sine is opposite over hypotenuse. In this case, the opposite of this 45 is 1, and the hypotenuse is the square root of 2. So the sine of 45 is equal to 1 divided by the square root of 2. Now I have to rationalize the denominator. So after I do that, I will multiply both the top and the bottom by the square root of 2. All right, so on the top, I'd have the square root of 2. On the bottom, square root of 2 times the square root of 2 is the square root of 4, which is 2. So it's root 2 over 2. Cosine of 45. Adjacent over hypotenuse. Now the adjacent is still 1. And the hypotenuse is still the square root of 2. So it's the same exact process. I still need to rationalize the denominator, multiply by square root of 2 over square root of 2, because the denominator is the square root of 2. And I end up with the square root of 2 over 2 again. These are the same. So the sine of 45 and the cosine of 45 is going to be the same. Tangent of 45. Opposite over adjacent is 1 over 1. So the tangent of 45 is 1. Okay? Now we'll look here with a 30, 60, 90 right triangle. So we're going to find the sine of 30. So reference angle is 30. Opposite, adjacent, hypotenuse. Labeled them all out. Sine, opposite over hypotenuse. That's 1 over 2. Cosine 30. Adjacent over hypotenuse, that's the square root of 3 over 2. And the tangent of 30, opposite over adjacent, O over A, is 1 over the square root of 3. I do have to rationalize the denominator, so I multiply by what's in it. Root 3, do it to the bottom, have to do it to the top. On the top, I get the square root of 3 over 3 times 3 is 9, so the square root of 9 is 3. Root 3 over 3 is the tangent of 30. If you get into trig, you'll know these very, very well. Go ahead and hit pause and give this one a shot of your own. Find the sine and the cosine of 60. All right, hopefully you had some success. So 60 is our reference. Opposite, across, adjacent, hypotenuse. Sine, 60 equals opposite over hypotenuse, root 3 over 2. Cosine, 60 equals adjacent over hypotenuse, that's 1 over 2. Okay, so hopefully you got those. Didn't have to rationalize. All right, one quick definition here. Angle of depression and angle of elevation. So an angle of elevation is found, like if I'm standing at the bottom and I look up, this angle here would be the angle of elevation. The angle of depression is always outside of the triangle. It's never inside of it unless you make a new one, okay? You can think of the angle of depression in relation to the movement of your eyes. You are standing at the top of the lighthouse and you look downward. So this angle here would be the angle of depression. Okay, I'm looking down. Now I could make another triangle here and make it a right triangle where it would be inside. But typically when I look down from something, it's going to end up being outside of the triangle that we're relating it with. Because if I'm standing up and I look down, we're going to know the height and we're going to know the distance. All right, now I could make this the distance and this the height by making a new triangle. But however, the original triangle, the angle of depression is going to be outside. Okay. Notice how the horizontal line in the angle of depression is parallel to the ground. Okay. So this makes it so that these alternate interior angles are congruent. So the angle of depression would be equal to the angle of elevation. Okay, so those two are going to be the same in relation to this triangle. So I'm going to do a couple examples here. It says you're skiing down a mountain with an altitude of 1,200 feet. So from here to here is 1,200 feet, okay? It says the angle of depression is 21 degrees. Find the distance x you ski down the mountain. So this is my reference angle, 21. 1,200's opposite. This piece is across from the right angle, so that is the hypotenuse. So we are going to have to use opposite and hypotenuse, which is sine. So the sine of 21 degrees, sine of the angle, equals opposite 1,200 over x. Put it over 1, and we'll cross multiply to solve. We've done this a ton of times. So we'd have x times the sine 21 degrees equals 1,200. Divide both sides by the sine 21. And we will have our solution. So 1,200 divided by the sine of 21 is 3348.5. So we'll round that up to 3349. And that's in feet. And then it says, in example 6, if the angle of depression is 28 degrees, find the distance I would ski down the mountain. So I'm going to change this to a 28. So my triangle would look something like so. 28 degrees, 1,200, right angle, finding x. Okay, so changing from a 21 to a 28. So still using reference angle, opposite, hypotenuse, sine again. Sine of the angle, in this case, is 28 degrees, equals the opposite piece, 1,200 over x. Put it over 1, and we'll cross multiply to solve. And I'm just going to do this one in my head, and I'm going to take 1,200 divided by the sine of 28, and I get 2556. And we have found it. All right, that's it for day 2. Have a good one.